The calibrated skulk sensor being added is the best thing since hoppers or might just be completely useless. We'll take a look at all the different things that can and cannot be done with it and what this means for the larger advancement of the redstone community. Hello there, Ray here, and before we take a look at what can be done with it, we need to take a look at some big misconceptions. Now, getting the new calibrated one is as simple as using a skulk sensor with amethyst shards. As I'll show, in some cases you do need a lot of them, in which case I do have a skulk farm as well as an amethyst farm. If you place a normal skulk sensor as well as a calibrated skulk sensor, just like this, they work exactly the same. The way the calibrated one differs is when you put redstone into the same side where the amethyst is coming out. And by putting different redstone signal strengths, we can make the calibrated skulk sensor only listen to certain type of noises. So notice now that this one's powered, when I walk, this one continues to hear my vibrations, where this one doesn't, because this one's only looking for a specific type, which is correlated with the redstone signal, and we're currently got a power at 15. So I put together this book which tells you what every single redstone signal is looking for. So if we go to page 15, this will tell you what the redstone power of 15 will do. So this will check for mobs and players dying as well as explosions. Let's set it to something else like number 13. This is checking for blocks being placed. So if we come back over here, instead of having 15, let's turn that off and let's turn on this one. So now the redstone signal, right before it goes into it, if you check that, this is 13. That means this skulk sensor will also look for whatever 13 is. And we know that 13 is blocks being placed. So right now I'm walking, notice that that one doesn't go off. This one will always go off no matter what type of vibration. But if I place down a block, notice that they both go off. If I do anything else, this one will continue to go off and this one won't. So this one's only listening to me blocks being placed, not broken. So if I place it again, you can see it goes off. But rather than having a whole bunch of redstone all over your place with different levers for different strengths, so you could program the skulk sensor however you want, we can simplify this whole thing just by having a lectern, which has a book with 15 pages, and we'll be reading the redstone signal that comes out of this. And depending on what page you have it turned to, it will change the redstone length. So page 1 will be redstone power 1, page 2 will be a redstone power of 2, and so on. So this does the same thing as a really long redstone line with a bunch of levers. But instead of having it going off that direction, we'll just point this comparator, taking the redstone strength that's inside of this, moving it out of this by using a comparator and pushing it into the skulk sensor. We gotta make sure we have the amethyst side pointing towards where the redstone is going into it. So now it's so much simpler. We can go ahead and set this to page 1, which is movement. So if we just walk, it's going to go off. Set it to page 2. Now walking no longer makes it go off, but jumping does. And so on and so on. So let's see how this compares with the new one versus the old one when it comes to using them to do certain things. So in this case here, we have a door which is going to open up, and we can program this one to open up for just jumping. So if a player comes over here and just walks up to the door, walking isn't going to open up the door. If they open up the chest or flick levers or anything like that, the door is not going to open. But if we jump, now the door opens up. Now for the old skulk sensor, we could do a similar thing. We could still program it. So in this case, we want it to shoot off an arrow coming out of the dispenser when the player tries to sneak in to take something out of the shulker box. That has to do with opening a chest. But for our little contraption, a redstone to work here, we have to set it one lower than what we want. So we're going to set it to that one. And this is going to remember that redstone signal and then try to subtract it from whatever redstone signal is coming from the skulk sensor. Well, because this skulk sensor listens to everything, even if I place a block, it's going to go off. If I jump, it's going to go off. If I walk, it's going to try to go off. So the way this works is that we ignore everything which is lower than what we want, and we also ignore everything higher than what we want. But that is all done with this redstone. So the old skulk sensor can still get confused with all sorts of noises which are occurring in the background. So if you happen to open up the chest and it's quiet, it will work properly. But if you happen to be walking as a player and then open up the chest, it was so busy listening to the player walking, it couldn't hear the chest actually opening it up. And that's the main difference between the old one and the new one. We don't have to worry about any other background noises confusing the skulk sensor since it's only listened to a very specific thing. So not only is the new one have a simpler redstone setup than that one, but it's also better at what it does. Well, both these skulk sensors are similar. Why do we actually have two of them and not just remove one of them and keep the other one? Well, this is because they're not exactly the same. As you can see here, when it comes to the original, it puts power out on all sides when it hears the vibration. But this calibrated one doesn't. You can see the side where we have the redstone going into it actually doesn't put off any power because this is where it's listening to input and can't do output there. On top of that, they also look different. This one looks quite well for like the ancient cities or the deep dark, where this one wouldn't really fit in. Also for builders, they probably got used to this one and enjoy this nice little look. Well, now this new one also gives them another thing they can work with, almost kind of like a little mad scientist table. So it kind of makes sense that they would keep the old and bring in a new one. But this also could mean that we could see some new types of pistons being added into the game soon. That's because if you power a piston really fast in Java Edition, despite the piston being a sticky piston, it can actually push a block up and leave it up there and not pull it back down. Where in Bedrock Edition, don't matter how fast you power an unpowered piston, it will always pull the block up and pull it back if it's a sticky piston. Because Minecraft is trying to make it so that things will act the same no matter what device or edition you are playing on, their goal would be eventually to get these two mechanics to be both in Java and Bedrock Edition, or at least one of them. But it makes sense that they would come in and just add in a second piston, one piston that could do this type of behavior, and one piston that would do this. That would keep both sides happy like they did with the Skulk sensor. We can also see this in budding or quasi-connectivity when it comes to piston. This is where you would come in and power a block above a piston. It's not directly touching it. And despite this being far away, this piston will actually extend using this power. But it doesn't actually currently know it's being powered, so any type of update beside it will cause it to extend. Now we can use different devices in between here to kind of update it. Here we're going to update this lamp, and that's going to update this note block, which is going to update the piston, so we can turn it off. Where in Bedrock Edition, they don't have this quasi-connectivity, so it would make sense that they could come in, add two different pistons, one with it and one without it, and they could even probably combine these pistons, so like one piston would have both of these properties, where the other piston would have both of these properties. This could also add a lot to the redstone community, especially for the Bedrock players who don't have these cool abilities. What do you think about this? We could take that contraption one step further by transporting the signal through a specific vibration wire like I got here. So this is one vibration, and one of the Skulk sensors heard it, and then it's pushing it into these amethyst blocks, which are then re-emitting the same type of vibration and just going down and all the way back around. So essentially this is a memory loop. It can remember any of the 15 different types of vibrations. But I want to go ahead and make it a little bit more compact, so I made this here. This is doing the exact same thing. The vibration is constantly being remembered as it's being put back through the entire system. So the vibration started here. It's getting sent off from this one over to this sensor, into this one, going over to this one, and you can kind of see it's going back and forth. And the reason why we have the wool is we want to make sure that this one doesn't send its noise to this one directly. The whole point of having this back and forth and distance thing is that we are creating a delay because we want the Skulk sensor to send out the signal, and then it has a bit of time where it can't take in any new signal. So it has to wait a little while, and then once it turns off, then it can take in a new signal. This is a little bit over 2 seconds, so we have to have 2 seconds worth of these little vibrations going back and forth until they come all the way around, and once this one turns off, then it can accept a new vibration and then continue the whole entire process. And this memory circuit is more compact than that one over there. They're also stacked in such a way where this one can send a signal over to this one, but this one can't send a signal back down to this one. So we can stop this memory loop from working by placing in a wool, which stops the vibrations from going through. Then we can reprogram it. So we're going to reprogram it with me flicking this lever, which is just going to remember the vibration of activating a block. So I'll flick that, and now the vibration goes into the system, and it's going to be remembered there. Now on the opposite side, we actually have another one of these systems, but this one we can put a different type of vibration into it. So let's put the vibration of me breaking a block into this one. So there are two different vibrations. They look the same. Only way we could tell is if we decode them. So what I got here is our little vibration wire, which is going away from the system over there. And currently we got this side blocked off, so we're not listening to vibrations from this one, but only this one. And they're coming through to over here, and then from here they're getting sent onwards, and they're making their way all the way to our decoder over here. So with the decoder, we can decipher what type of vibration is initially being sent. Currently we got set to checking for any type of deactivation, such as like turning a lever off, and it's not that one. So if we change this to block activating, now you see it works, because what we did was we activated this lever and it remembered the activation vibration. And that vibration is being sent down our vibration line, and it's making it here to our decoder. And if we had enough of these, we could actually check for every single one at the same time. We can figure out what type of signal is being sent. Let's go ahead and check the other signal. So let's close that one off and turn this one on. So now this signal is making it into our vibration line, and it's making it down here, but we don't have this one calibrated correctly because it's currently set to blocks being placed. We need this set to blocks being destroyed. And one set, you can now see this one lights up. So we use a single redstone line to send different types of signals to the end. So currently you can see the right lamp is being turned on, and if I turn off this side and I release this one, you can now see the left lamp is being turned on. We get 15 of these memory circuits all set to different types of vibrations. We get 15 decoders over there deciphering the message. And just with these, you can make a 4-bit computer. This seems all cool and everything, but there's a few problems. Well, first off, when it comes to this vibration line, we can only have these 8 blocks apart from each other. If it's any further, they can't send the vibration. 8 blocks is a decent distance if you're trying to like kind of jump over top of something in the center. But if you're trying to go really long distances, 8 blocks is definitely not enough. In which case it's better probably to use some type of wireless redstone to activate things far off. And even having like a redstone line or a rail line would probably be better in the long run than having a whole bunch of these skulk sensors with amethyst, as this would get kind of expensive over time. Next problem has to do with the memory circuit. You could accidentally come in here and reprogram the noise that is being held by one of these skulk sensors. So you would have to keep these isolated by having wool so nothing else could accidentally reprogram them. Or you'd have to make the time which it takes for the vibration to go all the way around to be so precise that there is almost no time for anything else to reprogram it. With my setup here, it's almost tick perfect, but even then I was able to spam noises into it. Another thing is, these systems will actually just lose their vibration. I unloaded and reloaded this world a few times and it seemed to be working fine. And then one time I just came back and the vibration was just lost. It just somehow did not continue it. Probably has to do something with it being over a chunk border. And part of it being unloaded and part of it being loaded. Because it's very difficult to automate this system because anything you do, like pistons moving, trying to move stuff, could end up activating it and sending a different type of signal down the system. And these skulk sensors that are used for the vibration line aren't programmed to listen to any specific noise, and therefore they could accidentally pick up anything else that happens, like a bat flying by. This would mess up your end system over here as well. So instead of having to do all this wool, skulk sensors, and amethyst, if we just use a normal redstone memory circuit, we can actually be way more efficient at deciding which of the 15 redstone signals we should be using. And redstone doesn't jump out of its lines and start activating things far away like the skulk vibrations do. So with the new changes to the different things that the skulk sensors now listen to, does this actually affect my AFK fish farm? So here we have a skulk sensor in the center. It could be a normal one or one of the new ones, doesn't matter. And then when the player comes over here and stands up against the side, you can AFK this, throw in your fishing rod, and then just right clicking on the sign here. And right away you can see I got some XPs because the fish farm's actually working. That's because as soon as the bobber gets pulled down, you can see it gets moved. It actually activates the skulk sensor here. Because of the wool we have around it, it's just listening pretty much to the only thing that's right above it, which is the bobber. And when it moves, it just activates, creates redstone, and then opens up the trapdoor, allowing the player to pull in at the same moment that there's a fish on it. So the answer is no, it doesn't actually affect my fish farm. It works exactly the same way. Still the best fish farm that you can make, as it gets you all the different types of enchantments and other goodies. Overall, there was so much hype when skulk sensors were first announced, but you might notice that we don't really use skulk sensors that much inside of redstone. Let's see why this is the reason by using my example of my AFK LA breeding farm. So here the player would be AFKing inside this minecart with the shards in the offhand, and they'd be right clicking up against this note block, which is pulling out a music disc and putting it back in again to make allays dance, and then right clicking them so they will duplicate, producing excess allays. Well, there's a few things happening. We have the player actually placing like a music disc inside of a jukebox, which we could actually read with a skulk sensor. It's set to block activating, so when I place in the music disc, you can see it activates it. That way we can know the player actually placed it inside. And then we could use that to send the player off. Maybe even have a different one that can actually tell when I use amethyst shards up against these guys, or we can even tell when the allays duplicate as it would be with the mob spawning in one. But instead of trying to detect all the different things, it's so much easier if we just use a little bit of redstone like we have here to do the exact same thing. Another big question comes to how they actually change the vibration frequencies and the redstone signals they produce. Because with this latest snapshot, they took all these different types of events that occurred in the Minecraft world that used to be detected by skulk sensors. And now there's just these. So I went through all the old ones and tested them in the latest snapshot to see if the skulk sensor would still notice them. And it seems that every single one is now in this new list. They're just more organized, which is a good thing. But if you happen to find something that used to work in the past, but is no longer going to work in 1.20, let me know. Now leave a free like or share this with somebody. Otherwise, you can always support me financially over at my Patreon, where I offer unique rewards for my supporters. Now use this playlist to make an automatic farm for everything in the game of Minecraft, or this one all about complex farms. I'll see you in the next one. Bye bye!